Okay, so this is tutorial number 1 and tutorial 3. Question number 1. Number 1. Let's say we have the 1.5 kilogram block, okay, slide along a smooth plane and strike a non-linear spring with a speed of v 4 meter per second. Right, so the spring is termed non-linear because it has a resistance of F is equals to Ks squared, okay, where K is 900 Newton per meter. Okay, determine the speed of the block after it has compressed the spring S equals to 0.2. Okay, so kita ada block, we have this block moving with V is equals to 4 meter per second, right? So, and then spring will compress for around 0.2 meter, right? So what is the speed of the block after it was compressed? Okay, so you can use principle of work and energy method for this problem, right? So for revisions, if you remember, so for principle of work and then energy, we have T1 plus summation of U12 is equals to T2, right? Where T is your kinetic energy, U is the work done, okay, from moving from point 1 to point 2, right? So first we need to draw the FBD. Okay, this is your free body diagram. All right. So we have weight of the block, which is 1.5 times 9.81, and then we have a normal force. All right. Kemudian we have the spring force. Okay, F is equals to Ks. Okay, F is equals to Ks. Right. So you can masukkan ke dalam principle of work and energy equations. Okay, this is principle of work and energy equations. So what is T1? T1 is equals to half kinetic energy, which is half mv squared. Right. So you masukkan, you have half. Okay, half. This is m, this is v. Okay, m setengah mv kuasa 2. And then we have T2, which is half mv squared. Okay, v final. Okay, cuma masalahnya kat sini lah. Okay, yang ini. This one is work done by a spring. Okay, work done by a spring. Kalau kita ingat, in our last lecture, work done by a spring is apa? Work done by a spring is equals to half Ax squared, kan? Right? Negative. Okay, negative. Ini kalau spring itu constant. Okay, kalau spring constant. Kalau tak constant, you kena integrate lah. You kena integrate. Integratekan spring force untuk dapatkan work done. Okay, work done. Mana nota dulu sekejap saya buka. Kalau siapa ada nota, you can open your notes, right? Sekejap. Okay. Mana ni nota dia? Okay. Sekejap mana tadi? Chapter 3. Okay, this is not lah for chapter 3. Mana work done by a force spring? Ini. Okay, work done by a force spring is U12 is equals to integration of from S1 to S2 Fs ds. Okay, in our case, Fs is constant, which is Fs is equals to K. Okay, kalau Fs is equals to K, which is if equals to Ks, so you can simply setengah Ks squared minus setengah Ks1 squared. Okay, for this case, F is equals to Ks, right? Kan? F is equals to Ks. So you integratekan Ks ds, you will get half Ks squared minus half Ks squared. Yang ni yang kita go through last week. Okay, this equation is valid only if your spring is linear. Okay, the linear means that F is equals to Ks. Okay, F is equals to Ks. B, spring tak linear. I mean, it's not linear, which is Fs is equals to Ks squared. So you have Ks squared. Okay. So bila tak linear, kita kena buat daripada asal lah. We have to integrate, which is U is equals to integration of from S1 to S2 Ks squared V ds. Okay. So that's why you have this work done by a spring. Okay. If your spring is linear, okay, you have F is just equals to Ks. Okay. You can simply integrate macam biasa lah. Ks ds. So you will get U is equals to half Ks squared. Right? Ini yang kita guna ya. Okay. Biasanya. Alright. So you integratekan macam biasa, you will get value of V is equals to 3.58 meter per second. Okay. So ini boleh integrate kita boleh integrate macam biasa ni. Okay, ini kalau kita integratekan kita dapat 900 S cube over 3 kan. So masukkanlah 0.2 and 0. Right? Okay, so you akan dapat jawapan V is equals to 3.5 dapat. Right? So that is question number 1. So the keywords dia ialah you just use the principle of work and energy. Alright. Okay, so this one smooth plane. Okay, the term ni smooth plane ni maksudnya no friction lah. Okay, no friction. Actually, when it's no friction, you can also use the conservation of energy. Okay, ingat dalam chapter ni we have two. One is principle of work and energy. This one. And then we have another more, which is conservation of energy. This one is principle of work and energy. And then we have conservation of energy. Conservation of energy. Okay. This one kalau you ingat, kita ada T1 plus V1 is equals to T2 plus V2. Okay. Di mana T is kinetic energy and V is potential energy due to gravity and also due to spring. Okay, due to spring. Only use conservation of energy when there are no friction. Okay, so when no friction like this one, you can use conservation of energy. Tapi masalahnya, problem ni dia use principle of work and energy boleh. Okay, tapi untuk mudah, you also can use conservation of energy. Sama je, you can try. Okay, for example, you can try T1 plus potential energy of spring elastic 1. Okay, is equals to T2 plus potential energy of ST at point 2. Okay. Cuma yang dekat point 1 ni jadi 0 sebab it's no compress kan, dia tak compress. So it become 0. So you left only kinetic energy for point 2 lah. So which is this one. Okay, sama je. Okay. Okay, question number 2. This is question number 3. Okay, question number 3. Sorry. Okay, question number 3. Okay, we have 750 mm. Okay, 750 mm long spring is compressed and confined by a plate P. Okay, kalau tengok kat sini we have 600 mm. Right, tapi cakap 750 mm. That means our spring is already compressed lah. Dah compressed dah. Alright. So which can slide freely along a vertical 600 mm long roads. Okay, so the 40 kilogram block is given a speed of V is equals to 5 meter per second when it is H is equals to 2 meter above the plate. Determine how far the plate move downwards when the block momentarily stop after striking. Okay, so kita ada block ni jatuh ke atas plate ni. So plate ni dia akan turun lah. So plate ni akan move down a bit. Okay, so how far plate ni turun. Okay, how far the plate ni akan turun. So you can use principle of work and energy. Ada friction tak? Tak ada kan? Is there any external force? Also tak ada. So you can use conservation of energy. Okay, no friction. Use conservation of energy. Okay. Apa equation dia? T1 plus V1 is equals to T2 plus V2. Okay. Yes. Okay, so potential energy. V is a potential energy. V is potential energy due to spring and also due to gravity. Okay, ingat V is potential energy, spring dan juga gravity. So let's say we have a datum in figure A, figure tak ada. Okay, the gravitational potential energy of block at position 1 and 2 are Vg1 is equals to mgh. Okay, let's say our datum here. So untuk gunakan conservation of energy, you need to set datum. Let's say we set datum here. So here is our datum, right? So at position 1, okay, at position 1, the Vg1 is, yang ni kita boleh kembangkan lagi. You have T1 plus Vg1 plus V elastic 1 is equals to T2 plus Vg2 plus V elastic 2. Right? So Vg1 is mgh. So since, let's say this is position 1, okay, since our datum is at position 1, so Vg1 is equals to 0, okay, and Vg2 is equals to mgh, okay, mass times gravity times height. Okay, contohnya selepas satu ketika blok ni jatuh. Okay, this block is jatuh kat sini lah, contohnya kan, jatuh kat sini. This is spring. Okay. So this is your delta, let's say this is your y, right? And then tinggi ini adalah 2 meter, right? So this is position 2. Okay, so how far is your block tu akan jatuh? Sebanyak mgh juga. The rumus is still mgh, which is mass times gravity times h, minus 2 plus y. Okay, 2 plus y. So put minus sebab our location is below the term, right? So you have this expression. Okay, the compression of the spring when the block is at position 1 and 2 are at S1, which is 0.75 minus 0.6. Okay, so at position 1, so pada keadaan 1, the spring is already compressed around 75 minus 6. Sebab apa? Panjang asal spring is 750. Okay, they compress with 600, so you just minus lah. We have 0.15. And then the spring at position 2, we have which is S1 plus Y. Okay, so they compress more around Y when the block is go down. Okay, and then plus the original compression, which is S1. Okay, so you have 0.15 plus Y. Okay, then initial and final elastic potential energy of the springs are half ks square. Okay, ingat kalau spring itu linear, the expression is just half ks square. Okay, kalau tak linear tadi, you need to integrate. Okay, you have half k and then s1 squared, you have 281.25. And then for position 2, you have half ks squared juga, cuma s2 adalah s2. Okay, yang ini. Alright. Okay, and then for conservation of energy, you just simply plug into the equation. You just plug into the equation, which is this is T1 plus VG1 plus VE1 is equals to T2 plus VG2 plus VE2. Okay, so you have this expression. Okay, so 0 is potential energy at position 1. This is elastic energy at position 1. This is kinetic energy at position 2. Apa? But they said that how far the plate move when the block stop. Okay, so bila block tu stop, velocity is 0 lah. So you have T2 is equals to 0. Okay, so you plug in everything in these equations, right? So you will get the quadratic equations, okay, with y squared in there, and then solving for the root, you will get two answers. One is positive and one is negative. So you take the positive one, which is you will get y is equals to 213 mm. Okay, so this slide I will give to you later in the unit. Okay, question number 6 in tutorials. Again, we have the spring. Okay, we have 5 kilogram coiler, has a velocity of 5 meter to the right when it is at A. So let's say this is A. So initially dekat sini, right? So they move 5 meter per second. It then travel down along smooth guide. Okay, smooth guide means that no friction. Okay, no friction. Setiap keywords tu penting boleh tahu. It's most guide, no friction. Determine the speed of the caller when it reach point B. Okay, so they can reach dekat sini lah. Point B. Determine the speed. Okay, point B, which is located just before the end of curved portion of the roads. Okay, the spring has an unstretched length of 100 mm. Okay, and is located, MB is located just before the end of curved portion of road. Sama, diulang balik. Okay, so what equation you can use? So no friction kat sini satu keywords yang penting. Okay, this important keyword. So you can use the conservation of energy, right? Which is you can use T1 plus V1 is equals to T2 plus V2. Okay. So kalau kita nak lebihkan lagi, you can have T1 plus VG1 plus V elastic 1 is equals to T2 plus VG2 plus V elastic 2. Right? Alamak, tertindih pula. Saya tulis dekat alamak, hang pula. Okay. So you have apa tadi? We have T1 plus V1 is equals to T2 plus V2, or T1 plus VG1 plus V elastic 1 is equals to T2 plus VG2 plus V elastic 2. Alright. So we start with what? You can start any lah. We can start with kinetic energy. We can start with potential energy. Okay. Let's say we start with potential energy, which is Vg. Okay. So Vg. So dalam kes ni dia tak panggil 1, dia panggil A. Okay. Tak apa. A pun boleh, 1 pun boleh. Okay. Let's say Vga is equals to mgh. Okay, let's say our datum adalah dekat B. Okay, dia set datum kat sini. So this is our datum. You can set datum at A as well, no problem. Let's say this is our datum. So VGA adalah mgh, mass times gravity times height. So we have 5 times 9.81 times 0.2. So this height is height between point A and datum. Okay, ukurlah antara point A dengan datum ni berapa height dia. So this is HA lah. HA is equals to 0.2 meter. Okay. And then we have V gravity at B. V gravity at B is 0 sebab apa? Dia lies pada datum. So kat sini datum, kat sini juga nak cari VB. So this is 0 lah. Okay. Sebab apa? Sebab H dia adalah 0. Okay, then this is potential energy for gravity, and then yang bawah ni adalah potential elastic potential. Okay, this is VE. Okay, so at A and B, the spring stretch at A. Ni kena imajinasi tinggi sikit ni. Yang lagi. Okay. For example, pada A, okay, pada A ni kan. So berapakah panjang spring pada A? Panjang spring pada A adalah 0.2, yang itu pun 0.2. So okay, so here is 0.2, so kat sini pun 0.200 mm. Okay, so distance ini adalah inilah 0.2 plus 0.2 square dan square root. That is the length of ini. Okay, right, so minus 0.1. 0.1 is the original length ataupun unstretched length of the spring. Yang ini bagi dalam soalan. Unstretched length of the spring is 100 mm. So you tolak je lah. Tolak 0.1, you will get SA is equals to 0.18 to 8. Okay, and then at B, kalau dekat B, panjang ni adalah 0.4 kan. This 0.2 plus 0.2. Okay, distance here is 200. Distance here is 200. So you have 400 mm. Okay, or 0.4 meter. So 0.4 minus dengan 0.1, which is original length, uncompressed length of the spring. So you get 0.3. Okay, 0.3. And then you can plug in into the elastic potential energy, okay, which is half Ks squared. Okay, so half Ks squared ini, okay, half Ks squared. So you dapat K is compressed coefficient of spring. You dapat ni lah. Okay, and then VE dekat point B, you just plug in half Kx squared, you dapat 22225. Right? Okay, kemudian masukkan ke dalam conservation of energy punya equations. Okay, so you have TA plus VA is equals to TB plus TB. Tadi saya pakai T1 and T2. Okay, that's no problem. You can use AB or 1 ataupun 2. Alright, so this is your TA. This is your VGA, right? And then this is your VEA. This is your TB. This is your VG at B. And then this is your VG elastic. No, bukan VG elastic. VEB. Okay, this is VEB. Right? V elastic at B. So you dapat ini VG. Okay, inilah expression ni. You can solve for V. So idea dia, the concept dia, you just use conservation of energy, these equations. Right? Or you can use this equation lah yang kat atas ni. And then you find each term and then you plug in into the equations. Okay, boleh?
Boleh.
Mahal je. Tak siap lagi Tanya apa pula? Determine the speed of caller at point B. The speed... Tak tanya pula soalan sini. Macam salah soalan ni. Oh, dia tanya normal force. Okay, mungkin soalan dia tinggal. Dia asking for normal force. Okay, normal force of caller. Okay, so kalau dia tanya normal force of caller, you can use equation of motion lah, macam what we have learned at chapter 2. Okay, chapter 2. So you can draw first. You can draw your free body diagram. Okay, so at point B. Okay, at point B, normal force of caller at point B. At point B, right? So at point B, so this is curve motion. Okay, this is curve motion. So you have A normal and also A tangent. Dan kita ada F spring. Dan kita ada normal force. Okay, normal force. Dan kita ada weight, berat. Right? So gunakan F is equals to MA. So you have normal and plus 15. 15 ni datang daripada force spring lah. This is force spring. Kita kira guna F is equals to Kx. K is 50 and X is 0.3 at position 2. Okay, sama dengan ini. Right, same with this one. So you have 15 lah. 15 is equals to MA. This is M and this is A. A apa? AN. Okay, ingat untuk rumus AN adalah V squared over rho. Okay, so you have V squared over rho. Rho is your radius of curvature. 0.2. Okay, bukannya 0.4 Radius of curvature is just 0.2. Okay, you have V squared over rho. So you can dapat lah what is the value of N. N is equals to 694 Newton. Right? Okay. Ini soalan apa pula? So you have two spring and then you have a box falling. Box jatuh daripada atas. Span of negligible mass. Span tu apa? Span tu kuali Itu apa? Span of negligible mass is attached to identical spring of stiffness of K 250 if a 10 kilogram box is dropped from height 0.5 meter above the fence, that means the maximum vertical displacement D. D tu nak tahu. So D yang inilah maximum dia how much. Okay. Initially, each spring has a tension of 50 Newton. Okay. So pada keadaan spring ni straight ni, ini. So the tension dia adalah 50 Newton. Okay. So it's no friction, no external force. So you can use conservation of energy. Right? Iaitu T1 plus VG1 plus V elastic 1 is equals to T2 plus VG2 plus V elastic 2. Right? Okay, start with potential energy. Depends dekat mana kita set datum. Okay, let's say we set datum at point 1. Okay, let's say we set datum at point 1. So VG1 is equals to 0. Okay, sebab apa? Datum pun dekat 1. So VG1 is equal to 0. And VG2 is MGH. Okay, so this is M. So this is G. And then this is H. H adalah is kosong 0.5 plus D. Okay, distance between top to bottom. Apa distance dia? You have 0.5 plus D. Right? Minus sebab dia berada di bawah datum. It's located below datum. So you need to put minus sign. Okay. So simplified, you have minus 98.1 times 0.5 plus D. Right. So initially the spring stretch. Macam nak tahu spring itu stretch tak stretch? Sebab it's given that initially each spring has tension of 50 Newton meter. Okay, ingat force spring adalah F is equals to Kx. Okay, if you have tension 50, so K is 250, so you will have what is X kan? So mesti dia ada satu nilai X. So X is just equals to 50 divided by 250. So you have this expression. Alright. 50 divided by 250. So you have 0.2. So pada keadaan asalnya spring tu dah mungkin dia compress lah, dia tension lah, okay, 0.2 meter. Alright. Oleh itu, unstretched length of the spring is 1 minus 0.2. Okay, so you have 1 here, minus lah dengan 0.2 yang dia dah stretch 0.2 tu. So original dia sebenarnya kat sini je, mungkin dekat sini je, okay, around sini, 0.8. So dekat sini adalah 0.2. Okay, so 0.8 is your unstretched length of the spring. Okay, and then the initial elastic potential for each spring is, so you have VE1. So this is VE1 setengah KS square. So darab dengan 2, sebab apa? Sebab kita ada 2 spring. Okay, we have 2 spring, just times 2 lah. Okay, you have 2 times half KS square. Ini sebab we have 2 spring. Right? So you get VE1 is equals to 10 joule. Okay, 10 joule. Ingat our units for this adalah joule. Joule, ini pun joule. Joule or Newton meter. Okay, samalah dengan is equals to apa ni? Joule lah, joule. Tak jadi pula joule. Right? Okay, when the bob is at position 2, the spring stretch sebanyak d squared plus 1 squared square root minus 0.8. So what is length for this spring? Length yang ini adalah d squared, kan, panjang ini d squared plus 1 squared and then square root lah, segitiga. Okay, this is just segitiga lah. Ini d, here is 1, so yang sini adalah d squared minus 1 squared square root, right? Minus 0.8 original length of your spring. Okay, original length of your spring. So the elastic potential energy for the spring at position 2 is, so this is VE2 is equals to 2 times half KS squared. 2 sebab you have 2 spring times half KS squared is equals to solvekan lah, masukkan S tu D square minus ni, alright, you solvekan ni, alright. So equation ni agak susah untuk kita solve pakai calculator or using your math. So apa yang kita buat just saya terima dulu kan, nanti kita guna trial and error. Okay, and then plug into the equations of conservation of energy, alright. So at V1 0 sebab dia start from rest. Okay, VG1 is also 0. V elastic we have 10 joule. Okay, we have 10 joule, right? And then half mv squared ini juga 0 sebab dia dah stop. Okay, maximum vertical displacement D, so start 0, ujung-ujung pun jadi 0, right? So we have 0 as well here. So plus this is VG2, this is VG2, tadi kita ukur kat sini, yang ini VG2, right? Plus VE2, okay, this is VE2. Okay, simplify kan you akan dapat ni lah. Okay, adanya square and then you have a square root. Okay, Kalau you squarekan semua, you kena solvekan d to the power of 4. Okay. You can solve the equation by using try and error. Choice lah. Okay. Kalau you guna Excel, you can try. Okay. Guna MATLAB. Tapi soalan macam ni kita tak tanya lah dalam exam. Okay. Untuk kalau assignment tu mungkin sebab you boleh guna Excel. Right. So you dapat D is equals to 1.3. Right. Okay. This is equation number 7. Konsepnya sama. Okay. Gunakan conservation of energy. Okay. Conservation of energy. Okay, we look into the, I think, last questions for tutorial 3. I just select a few questions, all right? Okay, let's say we have this roller coaster. Car has a mass of 700 kilogram, including its passenger. If it's released from rest at the top of the hill A, determine the minimum height of the hill so that the car travels around both inside the loops without leaving the track. Neglect friction, mass of the wheel, and size of the car. What is the normal reaction on the car when the car is at B, and what is it is at C? Okay, so take row B 7.5 and row C is 5 meter. Okay, so what is the minimum height so that the car is moving around loop B until loop C? Okay, if we put highest, the maximum is okay. Okay, kalau kita letak the maximum H, let's say letak je lah H ni setinggi-tingginya, confirm dia akan sampai lah. Okay, tapi kita nak dapatkan berapakah, what is your minimum H? Minimum H supaya kereta ni boleh lepas sampai ke C. Okay, kalau letak tinggi tak ada masalah. Okay, tinggi tak ada masalah, tapi minimumnya berapa? Okay, so you need to do conservation of energy lah. Okay, so it said that it's no friction. Okay, so no neglect the friction. So you can use conservation of energy T1 plus, dalam case ni is no spring. Okay, it's no spring, so you have only one potential energy which is due to wake. So we have Vg1 is equals to T2 plus Vg2, right? It depends. Kalau kita pilih between point A and B, you can just write down as TA plus VGA equals to TB plus VGB. Okay, it's only between 2 points, either AB or either AC. Okay. Okay. So this is what it looks like. Your free body diagram. Okay. So they're asking the force. Okay, they're asking for normal force. So when they're asking for normal force, you're gonna lukis keluar ya. Okay, so you're gonna lukis FBD lah. So dekat mana normal force-nya? Okay, where is normal force? Sebab in our equation this one is no normal force. Okay, no normal force in these two equations or in the conservation of energy equation. So you need to draw FBD to locate the normal force. Okay, so we have normal force over there, and then we have weight of the passenger, and then we have A normal. Okay, A normal, right? So we have Fn is equals to MAN. Okay, so N plus 700 times 9.81. This is due to weight, is equals to MA. So this is M, this is AN. AN is equals to V squared over rho. Okay, let's say this is at point A. Okay, this is the same lah, either point B or point C, and then we can locate for each position. Let's say for position B, when the roller coaster car is about to leave the loop at B and C, so N is equals to 0 lah. So pada ketika when the car is just about to leave, dia belum leave lagi, so no, it's no normal force. Okay, it's no normal force. So you can put N is equals to 0 into the equation number 1. So you have 0 plus 700 times 9.81 is equals to MA. Okay, so you will get VB squared is 73.575. Or you can calculate lah, VB is equals to, say, square root of 73.575, 8.6. Okay, let's say this is 8.6 meter per second. So this is at point B. Okay, at point B. At point C, okay, at point C, use similar equations. Equation 1. The difference is on the row. Okay, row. So row for B is 7.5, and row for C is 5 meter. Okay, so difference dekat row lah. So you can calculate VC is equals to 7, right? 7 meter per second. Okay, so tengok dekat dua-dua ni, judging from above result, the roller coaster will not leave the loop at C if pass through B safely. Okay. Okay. So supaya dia dapat pergi, so that it can untuk sampai dekat C, dia mesti melalui B dahulu. Okay, it must pass through B before it can reach C. So N at 0 must be at B lah. So you should have VB is equals to at least 8.6. Okay, at VB, then it will be safe. Okay, and it will be safe. So NB is equals to 0. Okay, so then we go into the conservation of energy. So the datum will be set at the ground level. Okay, applying equation from A to B with VB squared is equals to 73.575. So you have TA plus VA is equals to TB plus VB. So this is from conservation of energy. All right. So at point A, the kinetic energy is 0. Okay. At point A, the potential energy for gravity is mgh. So this is m, this is g, and that is h. Let's say this is our datum. Okay, mgh. And then for TB, you have half mv squared. Okay, this is half mv squared. So we dapat yang tu. And then plus VB gravity. Okay, VBG, which is mgh. This one is mghb lah. Okay, hb. 15 meter. Okay, this one 15 meter. So you get the minimum h is 18.75 meter. Okay, 18.75 meter. Okay, so kita kena check lah. Okay, from B to C, we need to check which is TB plus VB is equals to DC plus VC. Okay. At point B, this is half mv squared. Alright, this is mgh. This is half mv squared plus mgh. Okay, so your VC is equals to 171. Besar daripada yang kita set kat sini. Okay, kalau kurang, dia akan jatuh lah. Okay, dia akan jatuh. So, tak sampai lah dekat C ni. Roller coaster ni dia akan jatuh lah. It will fall down lah before it reach point C. So, kalau lebih, tak apa. Okay, lebih tak apa. Alright, so substitute the result into equation 1 with rho C is equals to 5 meter. So, guna balik equation ini, plug in again, VC is 171, right? So, you get NC ataupun normal force is equals to 17.2 kilo Newton. Okay, so tak boleh anggap NC itu equal to 0. MB 0 is okay. Okay, at least it's larger than 0 lah. Okay. Alright. Soalan? Yeah. Okay, so I have solved 1, 3, 6, 7, 9. Okay, so yang lain tu you buat lah. You buat kat hostel dan tengok dapat ke tak jawapan. So this slide I will provide in the written, so you can have revision later lah. Okay. Kalau tak ada soalan, kita stop situ hari ni. Boleh? So siapa yang belum isi attendance, you can isi attendance. Password is dynamics 127. Password for today. Okay. Kita stop situ boleh? Kita jumpa selepas hari raya. Okay. So next week is a holiday, so we will see again the next after that lah. Okay. So kalau tak ada apa-apa, saya ucapkan selamat hari raya kepada semua. Maaf lahir batin kalau ada salah silap. Kita jumpa minggu lagi 2 minggu. Okay, terima kasih semua.
Okay, doktor.
Okay, doktor.
Ya, saya